Okay, in this short video, we're going to talk a bit at a pretty high level about the issue of privacy and confidentiality in blockchains. So we've already encountered a couple of things that might be relevant to this. As you remember, we've been using Etherscan to look at information about transactions and information about accounts and contracts. And so just for example, you may have noticed that when you click on one of the contracts that I, as the instructor, created, you can go see my instructor's address there. You may see that in addition to the contracts that I've created for this course, you can scroll down to all of the transactions ever that I've made. You can scroll down to not just the handful that show up on the page, on this first page of most recent ones, but basically the entire history of transactions I've made with this account. You can even go see. As just another detail of that, you may think that this only has to do with the Ropsten testnet, but actually the address that I have here is also a valid address on the mainnet. So if you go look at the same address, only some of the capitalization is different, the address is still the same, you can actually see real live transactions that I've made on the actual Ethereum mainnet. You can go see, for example, CryptoKitties that I've purchased, or a domain name from the Ethereum name system that I purchased with this. All right, so just using available information, you can track down a lot of information associated with addresses. Perhaps you might be surprised to think that someone can tell that an account that you use to participate in this class, for example, if you go and reuse it for other activities to buy domain names or whatever else you do on Ethereum, all right, it may come as a surprise to you, but hopefully after this video lecture, it won't be a surprise any longer that this information can be tracked on the blockchain. All right, so in general, this is a well-known problem. I mean, it's well-known among the research community and among people who are familiar with this, but it's maybe less understood by lay people, people who just hear about cryptocurrencies in the media and assume that everything that happens on a cryptocurrency is anonymous. In general, cryptocurrencies like Ethereum provide pretty poor privacy guarantees. So, I mean, in general, all of this transaction information is available on the blockchain and widely replicated, and so it can be traced. Now, besides just going and enumerating all of the activities that show up in accounts, you may think of doing something like, you may remember that we've looked at this a couple of times, that in MetaMask you have not just one account associated with your key, but actually a variety of different accounts. All right, so if I switch to each one of these different accounts and I can go create account to get more of them, all right, I can get a different address. So you might think, oh, I'll just use a different address for every different activity that I do, and that might, provide some privacy benefit, prevent my transactions from being correlated with each other. But for a bunch of reasons, even that doesn't provide, especially good privacy for a bunch of different reasons. Basically, there are a variety of techniques that altogether are called transaction graph analysis that allow someone who's doing surveillance or someone who wants to connect events together on the blockchain to be able to determine which accounts are related to each other. So for example, you might keep an Ethereum balance in two different accounts and then think that those are completely uncorrelated with each other. But you may end up trying to combine all of those accounts into one by sending all of the Ether you have into a single account so that you can make one large transaction, say, to deposit a coin at an exchange. All right, that could reveal the fact that those accounts are related or at least interacted with each other in some way. There are a bunch of research tools and in fact now professional services like Chainalysis and Elliptic that essentially provide the service to regulators, to law enforcement, and in principle to anyone, even other companies who want to get some kind of intelligence or information collection about which transactions or addresses are related to each other. If you go to the Chainalysis website, for example, you can see that the applications that they're targeting are bad activities like fraud and compliance violations, and so their intended customers are regulators and law enforcement like that. But essentially what they provide are transaction investigation software that combine information and some clever techniques in order to connect events together that take place on different cryptocurrency blockchains. Some of the subtle techniques involve active techniques, for example. So One clever idea is that if you want to find out which accounts may be associated with a particular use or to an exchange, for example, right, you can try to make deposits to an exchange or to a service. And even if this service generates a unique address for you to make this deposit to it, you can see what happens to that transaction afterwards. So you may send coins to a unique address, but then you may watch on the blockchain, watch on Etherscan to see where those coins get sent next. And more often than not, or in a lot of cases, those coins get scooped up into one larger wallet or into some particular smart contract. And from this, you may realize that, okay, all of the transactions, all of the addresses that sent coins that ended up in that smart contract may be owned by the same exchange or are related to each other. So there's a variety of techniques that have the effect of clustering addresses as having a common owner or being related to each other for a similar purpose. And all of these can make events or activities, behaviors that you may carry out and may think are completely unrelated or unassociated with you actually traceable to each other. So one research paper that came out that was one of the pioneers of transaction graph analysis in cryptocurrencies, in Bitcoin especially, essentially traced a chain of transactions and related them by common behaviors, like they used similar timing patterns and similar amounts in each transaction. And they essentially provided some evidence that the founder of Bitcoin, Satoshi, was related in some way to the founder of the Silk Road, one of the black market exchanges that was very widely used in Bitcoin in 2013, the Dread Pirate Roberts. And essentially, they drew this connection between these transactions and made a published article about it that drew this connection. That would be really surprising information and maybe a problem for Bitcoin if it turned out that the Bitcoin's founder was also the founder of the black market website, the Silk Road. Now, this turned out to be a false positive, a false analysis. What happened is that these initial coins that were purported to be from Satoshi, Bitcoin's founder, were actually claimed by a security researcher who said, look, I can explain where these came from. I was an early adopter of Bitcoin and mined some of these coins early on, but I wasn't the founder of them. And also the coins did not go directly to the Silk Road, but instead he simply deposited them at Mt. Gox, one of the Bitcoin exchanges operating at that time. So there's an explanation that explains why this transaction graph analysis led to a false inference. But all this goes to say is that even when transaction graph analysis isn't perfect, right, it can still have an impact by drawing, suspicions or increased doubt about people that might, incriminate them or lead them to unwanted attention. So that's something to be aware of. We see transaction graph analysis show up in a lot of other contexts as well. So, for example, there have been crimes involving ransomware, which is malware that infects your computer and then encrypts your files and then asks you to pay a ransom in Bitcoin, for example, in order to get your coins unlocked. And now what happened with this WannaCry ransomware, or the CryptoLocker ransomware, is that it required ransoms to be paid all to similar Bitcoin addresses. And as a result, people would report to law enforcement about these ransom transactions that they paid. And as a result, it's possible to trace those ransom payments. And so once it's clear that these payments are associated with a ransom, a criminal now owns the private keys associated with these ransoms that were paid. People are going to be watching the blockchain to see what the criminal does with those next and to see if they can get some information to trace these transactions and help them find them. Now, what happened in this particular story is that these ransomers tried to get their coins deposited into an exchange so that they could, make away with the coins and basically launder them, get them, exchanged in some different form where they're not so easy to track. And they tried to do this through a particular exchange, Shapeshift. But Shapeshift was quick to react to the fact that these coins were known to be associated with this illegitimate activity, with this WannaCry attackers, and so they basically prevented the coins from being exchanged and cooperated with law enforcement to effectively freeze those coins, take them away from attackers by not processing the exchange the way that the service ordinarily would. In a similar way, it's been possible to collect information about Bitcoin ransomware in similar ways by basically tracing the coins on the blockchain and therefore recording how many were paid to ransomers in different contexts. We see this also in the case of, we talked about this story in the case of the Parity wallet multi-sig failure, or the multi-sig vulnerability, which was exploited by an attacker to take funds from a bunch of ICO contracts that used the vulnerable Parity multi-sig wallet. And I think I pointed this out at the time, but just want to go over it again. The address of the attacker who did that was able to be traced, and in fact, this address still today has a balance of around $10 million worth of Ether. And these coins are hot because they are associated with this address. They are known to be the result of this theft. Etherscan actually marks them as a heist. And if whoever owns this private key tried to take them to an exchange to cash them out, the exchanges would be able to recognize these, and they would basically not process the exchange because they know to look for this address because it shows up on a list of, even just Etherscan maintains this list of other addresses thought to be associated with heists. So you can actually look here and see tens of $millions worth of Ether at the time in total that are associated with attacks. So all this goes to say that activities that you carry out on the Ethereum blockchain, for example, are not all super secret and concealed or confidential like you might expect. Instead, there's actually a lot of information that's available, and essentially the coins can be traced as they move from one address to another. Now, from the stories I've just mentioned, you may get the idea that the only topic here about privacy and confidentiality pertains to crime, but it's actually important to talk about privacy as an important desired goal. All right, cryptocurrencies aren't just useful for crimes, and there are a lot of legitimate activities for which we actually may really care about confidentiality and privacy about the actions that take place. So for example, people may be interested in activities that are somewhat sensitive, such as paying for medical treatments, paying for pregnancy tests, engaging in political activism, or donating to a political organization. And in these cases, you may be interested in having censorship resistance, avoiding being associated with these activities in a public way for fear of persecution or backlash. All right. For example, then, the Courage Foundation is one example of a nonprofit organization that accepts donations in the form of cryptocurrencies, and in particular, they try to recommend some techniques you can use to donate in a way that's anonymous or that's less likely to be associated with you. This is a nonprofit that essentially provides pro bono legal support to activists, for example. Another reason to be concerned about privacy, or to want privacy in cryptocurrencies, is that it's fairly well understood now that bulk surveillance of consumer data is a problem that's essentially a society-wide problem, because it leads to making people easier to target for phishing attacks, easier to target for social engineering. It can also contribute to people being vulnerable to discrimination. We don't want everyone in our society to have, massive records that are available to bad guys or to people that would take advantage of them. It essentially makes people weaker to have all of their information available in ways that we don't want it to be. A sort of analogous example is, I think, a story that's really interesting, which is the Venmo stories, which is that, so Venmo is not a cryptocurrency, but it is an online payment system. And this website telling this story is called publicbydefault.fyi. And essentially, Venmo as a payment system has an option to make all of your payments and metadata associated with them, any memo fields you may write with these payments, available online, where anyone can go on a website or use an API and enumerate them. Now, it's optional, so you can opt out or opt in to having your payments be available online with this information. But essentially, the problem here is that the opt-in was by default, so a lot of people who didn't know any better or had no reason to expect better would have their real name associated with their account. They would put descriptive memos about what their payments were, and they were completely surprised that all of this information was just available online for anyone to enumerate. And so this website lists a bunch of stories of people, for example, having a breakup, or essentially carrying out addictive behavior like gambling too much or shopping too much. And the surprising information is just this is a lot of information that people would consider private or sensitive. They wouldn't want just to be available to be enumerated on this website. And so it came as a surprise that it actually was. And so this is not a cryptocurrency, but the state of affairs is quite similar to what you would see in a cryptocurrency today, like Ethereum. People may not expect that all of the transactions that they make to smart contracts are all just available to be enumerated online, but really that's the case. There's a couple of other reasons to be interested in promoting privacy in cryptocurrencies. So for example, for businesses, the financial information or the activities carried out by a business are often considered proprietary information or sensitive information because competitors may try to use them to gain an advantage against businesses. All right, so for a business or a startup company or someone providing services to a startup company, the fact that all of the activities carried out on Ethereum may be publicly available or publicly enumeratable unless you take precautions, that can be a big problem for businesses, especially ones like financial institutions that have some special duty to basically protect the privacy of their customers, of their clients they provide service to. There's a final argument that I would make, which is that privacy is important for fungibility. So we like to think that it's the case that one Bitcoin is the same value as any other Bitcoin. They're all equivalent. Same with Ether. One Ether is the same value regardless of which account it belongs in. But because of this fact that transactions and accounts can be so easily traceable, there's no guarantee that you would get the same price in an exchange for a coin that, for example, comes from a hot account that has some association with, say, if an account previously made a donation to a contentious political organization or to a nonprofit like Courage Foundation, maybe an exchange would be more skeptical to just trade with it. Right? The fact that each coin may have a history from the accounts that it's passed through means that not all coins are necessarily worth the same as any others. Sometimes this topic goes by red listing or taint tracking, and it refers to the idea that people may trace the ancestry of coins and treat them differently based on what information can be gleaned from transaction graph analysis and other information like that. All right, so these are some arguments why we would actually prefer to have privacy in cryptocurrencies, even though by default, at least in the case with Ethereum and other major cryptocurrencies today, we don't get very much of it. Now, so far we've talked about transaction graph analysis and the idea of using the blockchain data to track information in accounts. But I just want to point out that that's only one of the kinds of sources of information that might threaten confidentiality and privacy. All right, there's also information on the peer-to-peer network itself. So when you run an Ethereum node, you connect to all of these other peers on the Ethereum network. Well, transactions that originate from your node may be identified as originating from your node, just due to the fact that they propagate over the network and they tend to propagate in a way that shows up from your node first. All right, so there are a handful of tools that essentially connect to lots of nodes on the network and try to identify which IP addresses are responsible for initiating each transaction. We haven't actually talked about running your own node on the network in this course. We've mostly talked about using the MetaMask interface right here. Now, what's happening when you use MetaMask is that every time you make a transaction, you are actually making a connection to, let me see if I can find the information here. I think I actually have to go to the options for MetaMask and go look into more detail about it. All right, but MetaMask is actually connecting to a service. Typically, the service by default is Infura.io. You can choose which one it is. If you ran your own node, you could configure MetaMask to connect to your own node. But by default, MetaMask is actually routing all of the transactions you send to a third party who then relays them onto the network for you. Well, that third party can see that all of these transactions are originating from your IP address. So even if you go here and change your different accounts, all right, this service that you connect to is going to realize that they're all still coming from your same computer, even though you're using different addresses. All right, so in that world, it's even worse. All right, even if you were able to take care of that, for example, you used something like Tor or a VPN so that you have a different IP address every time you make a different transaction with a different account. There's other information like timing correlation that could be used to relate your transactions to one another. And there are other side channels as well In a nutshell, just think of it that even if you use a different account, use different IP address to originate your transactions, it's likely that other information can leak that might be available to services like Chainalysis or spies or other people trying to do bulk surveillance that could be used to correlate your transactions and even associate your transactions to one address or to your IP address or personally identifiable information like that. Now, there are a lot of approaches to improving privacy in blockchains. I just want to talk at a high level about some of these. We won't really go into much detail. Really, the main point of this lecture is just to make you aware of this concern. So one concept is the idea of a permissioned blockchain. So far we've been using the public Ethereum blockchain for the purpose of this course. But there's a lot of interest in permissioned blockchains, which essentially, they're more like an ordinary distributed database in the sense that instead of a public peer-to-peer network, the network is run by a small set of nodes that are deliberately chosen to be mostly trustworthy. You still get some benefits by using blockchain technology, such as having replication, having some integrity guarantees through the use of hash functions and data replication. But the idea is that not all of the data would be all available just for anyone to go and download. On the other hand, in that case, you still have to trust the nodes that are running because they have access to all of the information that you would do blockchain analysis about. There are other approaches that are somewhat more involved that you could in principle use to obscure your activities. For example, mixing is the idea of sending your coins to a service that then you can then withdraw from a separate account, and as a result you would basically break the transaction graph connecting one account to another. Although this doesn't do anything on its own about the problem of timing information and your IP address being correlated with these activities. And by default, the Ethereum software like MetaMask doesn't provide any help for doing this. You would have to use a dedicated mixing-only wallet of some kind to do this. It's also more expensive because you have to make transactions on the blockchain just for this mixing. So it's somewhat of like an expert feature, and it doesn't address the problem that we would prefer for privacy to be available even just to ordinary users who don't go out of their way to try to mix their coins. I talked a little bit about the idea of compartmentalization, like you would use a different account for different purposes. This can be effective, but it's quite tricky, and again, it's not supported by default if you just use the MetaMask wallet in the obvious way. So it's something you could be aware of, but not something that's simple. There are a variety of additional techniques, which I'm just going to call advanced cryptography, which range from things like zero-knowledge proofs and ring signatures and multi-party computation. The only one that we've mentioned in the context of this course is commitments. So if you remember from the discussion about auctions and the rock, paper, scissors game, we already use a kind of cryptography called commitments, which is like a hash function plus some random value, so you can't just enumerate the space of the values you're trying to commit to. And anyway, this has the effect of putting some kind of information on the blockchain, the commitment to a value, without revealing what that value is, until in the case of the rock, paper, scissors, you go and reveal the value of the commitment later. Or in the case of an auction, a sealed bid auction, you go and reveal the value of your bid later. So what all of these have in common is that they make use of encrypted data or hashes of some data on the blockchain, but not the plain text of the data itself being placed on the blockchain. And these all range in terms of the kind of guarantees that you get about the data that's being committed to, but without revealing all of the data itself. These are more advanced techniques, so I'm not going to go much into them. I'll just mention that there are a lot of cryptocurrencies that feature some kind of privacy-specific feature. So Bitcoin and Ethereum by default don't provide private transactions, but several cryptocurrencies like Monero and Zcash and Dash specifically have privacy-preserving features built in. Not going to talk about how they work or the relative merits of these different approaches, just to point out that privacy is something that some different cryptocurrencies specifically aim to provide. And a last thing that I'll mention is that this idea of using advanced cryptography to provide privacy for smart contracts or for cryptocurrency transactions is a really active area of research. One of the updates to Ethereum that has happened is the addition of new opcodes, which are specifically aimed at providing smart contract programmers with access to some of this advanced cryptography. So I'm going to include in the extra information here a link to an article which describes an interesting application of a smart contract that has secret ballot votes, All right, voting is an example where you may want to have secret ballots in votes in order to keep voters feeling like they're honest, so that they're able to express their honest preferences without being persecuted for which way they vote. That's a good example of something where you would want advanced cryptography to support that application. So I won't go into much detail about how that works. I just want to point out that this is something that's, there's some partial support and ongoing development for this in Ethereum. It's still the case right now that it's fairly difficult to use. It's quite a subtle topic, so it's definitely an expert topic beyond the scope of this course right here. And I'll just say that for now, it's also still quite expensive to the point of really being impractical. So if you want to use one of these new opcodes for zero-knowledge proofs in Ethereum so far, it's going to cost you a whole lot of gas, a lot more gas than just checking a digital signature. So it's more advanced cryptography, and also in Ethereum you have to pay for it. So let me just wrap up. As I said, this is just a high-level discussion of the topic. The really high-level takeaway point from this is that you shouldn't by default expect that everything that happens on a cryptocurrency or on a blockchain is going to have a lot of privacy or confidentiality. If you don't know specifically what explanation there is for privacy or confidentiality, then you should assume that any action that takes place, or that users of your technology or of your smart contract take place, will all be publicly visible and potentially correlated with their real identity or with other transactions that they make. So by default, unless you specifically know better, you should assume that everything that's happening on a smart contract is probably visible to anyone who wants to go to look. You should also be aware that it's not just the obvious things like linking multiple transactions that all use the same account. Even if you take special measures to use different accounts for different activities, there are still other kinds of information leakage and side channels that can all be used to draw connections between different accounts and between different activities. And again, just to point out that this is an ongoing active area of research, so don't expect any privacy isn't the end of the story. This is just the end of the story for now for the purpose of this course. So the main point is just to be aware that privacy by default in cryptocurrencies in use today is quite lacking, so just be aware of that.